Good morning, children. Today we'll start chapter 9 of Maths paper 1A, Hyperbolic Functions. So what are these hyperbolic functions? You have seen these trigonometric functions, algebraic functions, polynomial functions and so on. Now we'll learn new type of functions called as hyperbolic functions. Now what are these hyperbolic functions? Before learning about these functions, first we'll learn this letter E, which is an irrational number. E is equal to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial. We call this as factorial. So actually what is 1 factorial? It is the product of first n natural numbers. N factorial is the product of first n natural numbers, 1 into 2 into 3 into so on till n. So on till n. This is n factorial. So 1 factorial is 1 only. So 2 factorial is 1 into 2, 1 into 2. 3 factorial is 1 into 2 into 3, like that. 4 factorial is 1 into 2 into 3 into 4, like that. So this is about n factorial. So E is defined as the infinite series. It is the sum of this infinite series 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial, so on to infinity. In general, e power x, we'll come across this e power x again in this chapter. So e power x is 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial, so on to infinity. This is the most general series of the expansion of e power x. When you put x as 1, you will get this e power 1. E power 1 is 1 plus 1 by 1 factorial plus 1 square by 2 factorial, like that. So this is about e power x. Now let us take x is equal to cos theta and then y is equal to sin theta. Now if you see, these two satisfy the equation x square plus y square is equal to 1. See, if you put x as cos theta, cos square theta plus sin square theta is always equal to 1. So if you take a point x comma y as cos theta and sin theta, cos theta comma sin theta, this is the most general point which satisfies this equation. So this point always lies on this circle. This represents a circle. And here theta is any real number. Theta is a real number which represents an angle. So x square plus y square is equal to 1 is satisfied by this point. In the same way, and so we call these cos theta and sin theta as circular functions. We call them as trigonometric functions and also circular functions. So using cos theta, sin theta, we write the remaining ratios, tan theta as sin theta by cos theta. And then cot theta will write as cos theta by sin theta. So like that we write no cot theta, then secant theta. Secant theta is equal to 1 by cos theta. 1 by cos theta. And then cosecant theta. Cosecant theta is 1 by sin theta. So all these sin theta, cos theta, tan theta, cot, secant, cosecant, all these 6 are called as trigonometric functions or circular functions because they satisfy sin theta and cos theta satisfy this equation, and all the remaining ratios are derived from those two ratios only. Now in the same way, if we take x is equal to, suppose that x comma y I'll take, otherwise any point as a into e power theta plus e power minus theta by 2, comma b into e power theta minus e power minus theta by 2. Suppose that this is a point. This point always satisfies the equation x square by a square minus y square by b square is equal to 1. You can see x is equal to this, no? So x by a. What is x by a? X is equal to, so when you equate, x is equal to a into e power theta plus e power minus theta by 2. So x by a is equal to e power theta plus e power minus theta by 2. Now when you square it, you will get e power theta whole square, that is e power 2 theta, plus e power minus 2 theta, plus 2. 2 into e power theta into e power minus theta becomes 1. So plus 2 by 2. Now in the same way, if you take y by b, if you take y by b and then y by b whole square, you will get e power 2 theta plus e power minus 2 theta plus minus 2 by 2. Now when you subtract these two will get cancelled and you will get 2 plus 2, 4 by this whole square becomes, this is 4. So here also it is 4. So 4 by 4 which is equal to 1. So you can verify. So it always satisfies, this point always satisfies the equation x square by a square plus minus y square by b square is equal to 1. So this is the equation of a hyperbola. This is the equation of a hyperbola, and you will learn about this in second year. You will learn in detail about this in second year. So now this, because these satisfy this hyperbola equation, we define hyperbolic functions. What are these hyperbolic functions? The formal definition of hyperbolic functions is like this. First you understand, then we'll write all the definitions. So suppose that f of x is a function. F is a function from R to R. F is a function, real function. Domain and codomain are subsets of real number set. And f of x is defined as e power x minus e power minus x by 2. This is called as the hyperbolic sine of x. This function defined in this way is called as the hyperbolic sine of x. Hyperbolic sine of x. And we denote this by sin hx. You must write sin h together. Hyperbolic sine of x is written. Hyperbolic sine of x is written as sin hx. So you should not write sine of hx. This is wrong. This way of writing is wrong. These two you should not write together. You must write sin h together and x separately, where x is any real number. So sin hx becomes, it is trigonometric ratio whose angle is hx. Like that we'll understand. So this notation is wrong. Sin hx is defined as e power x minus e power minus x by 2. This is the definition. You must learn this formula. So the hyperbolic sine of x is given by sin hx notation is equal to e power x minus e power minus x by 2. Next we define cos hx. Hyperbolic cosine of x. So hyperbolic cosine of x is defined as e power x plus e power minus x by 2. Okay. Next is tan hx. Hyperbolic tangent of x. Hyperbolic tangent of x is defined as sin hx by cos hx, like how you have in trigonometry. Sin hx by cos hx. Just to divide. We'll write all that now. Next is cot hx. Cot hx is like cot h of x. Hyperbolic cotangent of x is defined as cot hx, cos hx by sin hx. In the same way, secant hx. Secant hx is hyperbolic secant of x. Hyperbolic secant of x is defined as 1 by cos hx. 1 by cos hx. In the same way, hyperbolic cosecant of x is defined as 1 by sin hx. 1 by sin hx. So these 6 functions, sin hx, cos hx, hyperbolic sine of x, hyperbolic cosine of x, hyperbolic tangent of x, hyperbolic cotangent of x, hyperbolic secant of x, hyperbolic cosecant of x. These 6 functions are called as hyperbolic functions. Now we'll write these definitions. We'll draw the graphs and then we'll do some simple problems. So first we'll write e power 1. E or e power 1 is equal to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus so on to infinity. Next, e power x expansion. E power x is 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so on to infinity. Both are infinite series. Okay. Now next is and this e is approximately equal to 2.718. It is an irrational number. E is an irrational number. Okay. Next, in limits also you have this limit x tending to infinity of 1 plus 1 by x whole to the power x is e. We write there e. You will learn this in limits chapter of calculus. So there also it is the same e, irrational number e. Okay, next is we'll write the definitions of hyperbolic functions. So the definitions of hyperbolic functions. Definitions of hyperbolic functions. So suppose that the function f from R to R, first one, the function. So the function f from R to R, real function. Domain and codomain are subsets of real number sets. So defined by f of x is equal to e to the power x minus e to the power minus x by 2 for all x in R. Is called as hyperbolic sign. Hyperbolic is called as hyperbolic sign of x. Hyperbolic sign of x. Denoted by sin hx. So one definition we'll write in full form like this, and so we'll write sin hx is equal to e power x minus e power minus x by 2. Okay. Second onwards, I'll just write the formula. So hyperbolic cosine cos hx is equal to e power x plus e power minus x by 2. Okay, next third one is tan hx. Tan hx is equal to sin hx by cos hx. So when you divide these two, you will get e power x minus e power minus x by e power x plus e power minus x. Learn these definitions. E power, divide these two. Next is third one. Next, fourth one, cot hx. Cot hx is equal to cos hx by sin hx. Cos hx by sin hx. So that is e power x plus e power minus x by e power x minus e power minus x. 2 will get cancelled. Okay, next is secant hx. Secant hx is 1 by cos hx. 1 by cos hx is 2 by e power x plus e power minus x. Next is cosecant hx. So cosecant hx is 1 by sin hx. 1 by sin hx is 2 by e power x minus e power minus x. So in all this, x is any real number. So here x is a real number. All these are all called as, all these 6 functions. So I'll write here, these 6 functions are called as, hyperbolic functions. These are called as hyperbolic functions where x belongs to R. X is any real number. So these are the hyperbolic functions. Okay. Next, we'll draw the graphs of these functions. Secant hx. Yes. So now we'll draw the graphs of the hyperbolic functions. Graphs of the hyperbolic functions. So first one is y is equal to sine hx. Y is equal to sine hx. So your graph will be like this. Just rough graph you learn, that's all. Only the shape is enough for us. You'll get like this. So here the domain is real number set, and the range is also real number set. Now next one is y is equal to cos hx. Y is equal to cos hx. So this is x-axis, y-axis, this is origin. X-axis, y-axis, origin. So this is 1. You'll have a parabola, upward parabola like this. So this is the graph of y is equal to cos hx. Now for this the domain is real number set, and the range is just 1 to infinity. It takes from 1 to infinity. So range is equal to 1 to infinity. So this is the graph of cos hx. The next is y is third one. Y is equal to tan hx. Y is equal to tan hx. So the graph is like this. X-axis. So this is x-axis, y-axis, and you just draw a line. This is the line y is equal to 1, parallel to x-axis. And then another line like this. This is the line y is equal to minus 1. So your graph actually will be like this. Just to go through. So here the domain is real number set, and the range is minus 1 and 1. It lies between minus 1 and 1. Your graph lies between minus 1 and 1. So this is the domain and range. So next, fourth one is y is equal to cot hx. Y is equal to cot hx. So your graph will be like this. X-axis, y-axis, and then here you just draw the lines y is equal to 1, and this is the line y is equal to minus 1. So this point is 1 here, and this point is minus 1. Okay, so now you have the graph like this. This is y-axis. So it takes from minus infinity to minus 1. This is minus 1. And this is plus 1. So here the domain is real number set minus 0. Because when x is 0, cot hx is not defined. Okay. Denominator becomes 0. Okay. Then the range is minus infinity minus 1 union 1 infinity. This is the range, and this is how the graph will be. It will not touch. So this is a graph of y is equal to cot hx. Graph of y is equal to cot hx. Now next is the graph of y is equal to secant hx. Fifth one, graph of y is equal to secant hx. So this is x-axis, and this is y-axis. Now we'll draw a line like this. This is the line y is equal to 1. So it is the line y is equal to 1, and you'll have the graph like this. So here the domain is real number set, and the range is 0 to 1. It takes the value 1, but it will not take the value 0. It will not take the value 0. Okay, next is the graph of y is equal to 6th one. The graph of y is equal to cosecant hx. Y is equal to cosecant hx. So this is x-axis, y-axis, and you'll have the graph like this. Touch at infinity. So here the domain is real number set minus 0, and the range is also real number set minus 0. 0 element. Origin is not included. So just learn the shapes of these graphs. Learn the shapes of these graphs. In the exam, you may get these questions for 2 marks. You get these questions for 2 marks. Okay. Next is the we'll take sin hx. Next point. Sin h of 0. Next, one by one we'll write. Sin h of first point. Sin h of 0. Actually, what is sin h of x? Sin h of x is e power x minus e power minus x by 2. This is the formula. Suppose I have to write sin h of 2 theta. Then I should write e to the power, whatever x is there in that place, I should write 2 theta. So it is e power 2 theta minus e power minus 2 theta by 2, like that. So for all the functions, it is the same. In the place of x, if we have something else, the same thing you should write in the place of x in the formula. Now, suppose I need to find sin h of 0. X is real number. Real number I am taking as 0. Then it is e power 0 minus e power minus 0 by 2. What do you mean by what is e power 0? E power 0 is 1. So, e power minus 0 means e power minus 0 means e power minus 0 is 1 by e power 0. E power 0 is 1. So, 1 minus 1 by 2, that is 0. So, sin h of 0 is 0. Next is cos h of 0. Cos h of 0 is e to the power 0 plus e to the power minus 0 by 2. That is 1 plus 1 by 2. 2 by 2, that is equal to 1. Just learn this value. Sin h of 0 is 0. Cos h of 0 is 1. You can just learn the method also to find its value. Next is, we'll take f of x as, suppose f of x is sin hx. Sin hx. Then what is f of minus x? It is sin h of minus x. Sin h of minus x. What is sin h of minus x? E to the power minus x minus e to the power minus of minus x by 2. So what is it? E to the power minus x minus minus of minus becomes plus. So e to the power x by 2. So I can write this now as f of minus x now as minus of e power x minus e power minus x by 2. Take minus 1 outside, then it looks like this. So that means it is minus of sin hx. This is nothing but sin hx. So it is minus of sin hx. So that means it is minus of f of x. So we proved that f of minus x is equal to minus of f of x. So therefore, f is an odd function. F is an odd function. F is an odd function. So what is our f? Our f is sin hx. So f of x is sin hx. So sin hx is an odd function. It is an odd function. Now in the same way you can prove that cos hx is an even function. Cos hx is an even function. Let's see. So now we'll take third point is over. Next fourth point I'll write here. So cos h of minus x. Cos h of minus x is e to the power minus x plus e to the power minus of minus x by 2. In the place of x, I should write minus x. So it becomes e power minus x plus e power x by 2. This is same as cos hx. So f of minus x is same as f of x. If you take this as f of x, cos h of f of x, suppose that f of x is cos hx. Then you prove that f of minus x is equal to f of x. Implies that f is an even function. F is an even function. So even function, what is it? F of x cos hx. So cos hx is an even function. So it is an even function. So we found sin h of 0. Just learn the procedure how we are finding the values. That is enough. We need not by heart. Okay, cos h of 0 is 1. We proved that sin hx is an odd function. Cos hx is an even function. 4 points are over. Now next fifth one will write identities. Like how we have in identities. In trigonometry we have sin square theta plus cos square theta is equal to 1. And then we have 1 plus tan square theta is equal to secant square theta. And then 1 plus cot square theta is equal to cosecant square theta. In trigonometry, you have this formula. Now we'll prove the same similar things in hyperbolic functions also. In hyperbolic functions also we have similar identities. So in hyperbolic functions we have the identities as cos square x, cos h square. Okay, we should write cos h square. See here, cos square theta means what? Cos square theta means it is cos theta into cos theta. Okay, cos h theta or cos hx, cos hx into cos hx will write as cos h square x. You must write h square here. So this is wrong. Cos square of hx. This is wrong. You should not write like this. It should be cos h square. So the first identity is cos h square x minus sin h square x is equal to 1. Now the second identity is 1 minus tan h square x is equal to secant h square x. And the third one is 1 minus cot h square x minus 1. Cot h square x minus 1 is equal to cosecant h square x. So these are the identities. So we'll prove. The proof is like this. First one, learn the proof also how we are doing. Cos h square x minus sin h square x. So cos hx formula will write. What is cos hx? E power x plus e power minus x by 2 whole square. Plus minus e power x minus e power minus x by 2 whole square. Okay. Now we'll write this as what is a plus b whole square? A square. A square means e power x whole square. That is e power 2x plus e power minus 2x plus 2 into e power x plus 2 into e power x into e power minus x by 4. The LCM is 4. If you take LCM as 4, it will be like this. Again, this is minus e power minus 2, e power 2x minus e power minus 2x. Again, minus of minus plus 2 e power x into e power minus x. So if you see, you take minus, you square it, you will get like this. So these two will get cancelled. And this is also 1. So 2 plus 2 is 4. So 4 by 4 is equal to 1. So like this we prove the first one. Now to prove the second one, it will just take 1 minute. See, second one will write like this. 1 minus tan h square x will write as 1 minus sin h square x by cos h square x. cos h square x. So that is cos h square x, take LCM, cos h square x minus sin h square x by cos h square x. So cos h square x minus sin h square x is equal to 1. Just now we took. So we'll write 1 by cos h square x. 1 by cos is secant. So secant h square x. So like this we prove the right hand side. Okay. This is the right hand side. Hence it is true. Now in the same way you can prove the third one. You can just try. We will continue in the next video.
ఆ చదువులమ్మ నేరుగా ప్రతి ఇంటి గడప చేరగా మీ భవితకే భరోసా దూరదర్శన్ వేదికగా తెలంగాణ రాష్ట్ర ప్రభుత్వ సహకారాలే ఉండగా హాయిగా మన చదువులు అదే డిజిటల్ గురు